Hey everyone, welcome back to my channel EduVibe. As you all know that we already started the unit which is the momentum and impulse. Today we are on the next topic of that momentum and impulse, which is a more calculation based. So today we are doing the iterations in one dimension. In this video and in the next lesson we will do the iteration in one direction, but after that we will also do the iterations in a two dimensions too. So in this we are basically learn about the collisions and explosions. So how can we deal this with? I will tell you now today. So today's we will start with the hit and rebound first, then we'll move on to the other collisions too. So let's start with this topic by doing something. So this is the conservation of law of conservation of momentum. As you all know that the momentum which we learn, they have some laws in it. So this is the law, and if you see your data sheet, you get that conservation of momentum as physics principle number 4. So physics principle number 4 is the conservation of momentum. So what is conservation of momentum? So we see that before collision over there, and this is the after collision. Before collision and after collision momentum, if it is equal, so we can say that this is a law of conservation of momentum. So the total momentum before and total momentum after is equal, so we can say that it is the conservation of momentum happening. From here you get the conservation of momentum. So states that the total momentum of the system before an interaction is equal to the momentum of the system after the interaction, assuming no external forces are present. As you all know that in momentum we are not dealing with external forces. And this is physics principle 4. So if you know that you have some force net of any system which is equal to delta P, which is the change in momentum of the system upon delta T. So from here, if your this net system goes to 0, so what you get? That this thing is equal to 0. So that delta P system upon delta T is equal to 0. From here, if T goes over there, it comes to 0. So T cancel out. You only left with delta P system is equal to 0. From here, your delta P is also defined as final momentum of system minus initial momentum of the system, which goes to 0. So from here, your final system of momentum is equal to initial system of momentum. So this means that final momentum of the system is equal to the initial momentum of the system. From here, you can get that law of conservation of momentum. That if this is possible, if you don't need to yet memorize this, and we have to just understand this, how can we say that the before and after the momentum is same? This is only valid when there are no external forces present in the system. So no applied force is there, no tension, no friction, no resistance is there. There's a no external force if this is there. So we can say that this will happen. So the force of gravity is not an external force. So force of gravity is that force which is the part of the universe, and this will always there. The force of gravity is always there. So this is not a external force. External forces are these forces which I mentioned over there. So let's start with the collisions and explosions. There are three types which we have to learn in laws of conservation of momentum, which all three goes with the law of conservation of momentum law. So we are focusing on the hit and rebound collisions, where both then hit like this, they both are hit and they rebound, they go to their separate directions. Hit and skip, they will collide each other, and when they collide, they become the combined mass like this. And explosions, when they both collide and they will explode over there like this one. So we are dealing with all the three types of iterations which are on the laws of conservation of momentum. So first we have the hit and rebound collisions. So in hit and rebound collisions, if two objects undergo collision, we have two objects like we have number one, number two, they both are on the different direction. They come into that and they come into each other from the opposite directions. Can move in the opposite direction, in the same direction, or one of two would be at rest. If one to be at rest, or while other object moving towards it, there are some conditions which we dealing with in questions. After the collision, they rebond and do not stick together. They rebond. Like this will goes over number one, this was number two. They rebond and they go to the again separate. They didn't stick together. So if they didn't stick together, they travel independently. So that means is the hit and rebound. They hit and they rebound into the separate directions. So for this, how can we drive the formula for this? So if they are an initial first, so momentum 1 of initial plus momentum 2 of initial is equal to momentum 1 of final plus momentum 2 of final. So this will give you the formula for the hit and rebound. When you derive this further, you get m1 v1i plus m2 v2i is equal to m1 v1 final plus m2 v2 final. So this is the first formula of hit and rebound which you have to learn. This is not on your data sheet. You have to learn this. And that type of we have two more after this. All three you have to learn. Do you understand if you want? But you have to be memorized these things. But this is the thing which you have to use in the questions. So this is for the hit and rebound. So let's deal with the example first and then move on to the another collisions. So the first example states that during the game between the Edinburgh Athlete and the Calgary Stampeders, the stamp quarterback mass of this is finite at of 6.50 meter per second knot to try throw a pass. Running along the field in an Alclays, linebacker mass of 96.5 kg at 7.00 meter per second south. After the quarterback and the linebacker collide, the quarterback rebounds with a velocity of 5.55 meter per second south. So determine the rebound below velocity of the linebacker. So there's a lots of things going on. So we just made the things which we have given in this. So we have a mass of, we have two things. We have this and we have this. So we have a mass 1 and this is mass 2. So we have mass 1 of 89.0 kgs. Mass 2 we have 96.5 kgs. Then this mass goes with this velocity. And this is north. So we take north has positive and south has negative. So our V1, which is our I, V1I, because this is the initial one, not the final one. This is the initial one. This is of 6.50 meter per second in positive, and this mass will go with the 7.0 meter per second. This is in south, so we take this at negative. So this is our V2 initial, which is negative 7.00 meter per second, which is in south. After both are collide, quarterback rebounds with the velocity of 5.55 meter per second. The quarterback is first our first mass. So this means this was the final velocity of the first mass of the quarterback. So V1 final is equal to 5.55 meter per second. This is in the south direction, so we take it as a negative. And we have to find the velocity of linebacker. If this means we have to find the V2F. So to find this, we have the formula for this. Let's write the formula. M1 V1I plus M2 V2I is equal to M1 V1F plus M2 V2F. So we have mass 1 which is 89.0 kgs. We have V1I of 6.50 meter per second. Mass 2 is 96.5 kgs. And V2I is minus 7.00 meter per second, is equal to M1 is 89.0 kgs. V1F is minus 5.55 meter per second, plus mass 2 is again 96.5 kgs, and we have to find the V2F. This is not given us. So to calculate this, firstly solve this, the left side of the earth, because we have everything on the left side. So let's solve this, and when you solve this, remember the negative sign is over there and there's only one negative sign, so plus minus is negative. And when we calculate this, we get about 97 kg dot meter per second, which is equal to, so we now have this thing, these two things, we have multiplied this, and when we multiply this, we get about negative 493.95 kg dot meter per second, and this will plus with 96.5 kgs, and we have V2F. So this thing is over there. If we put this over there, this goes to positive. So when it goes to over positive, so we get negative and positive, we have to do negative suppression. So we get 396.95 kg dot meter per second, which is equal to 96.5 kgs V2F. Now this goes over down to there to divide it. So from here we get V2F 396.95 kg dot meter per second upon 96.5 kgs. Kg cancel. So when we divide, we get about V2F about 4.11 meter per second. So this is positive, so this is goes north. So this means that our rebound velocity of the linebacker is 4.11 meter per second north. So that's how you can deal with this. You have to find V2F, remain it on the line. When we get the chance to move over there, so you can move them over there. So this is the easy calculation for this type of question. You just have to know this formula. This big formula you have to learn. This is not very tough. You have to learn this. Hit and stick collisions now. So hit and stick is a more likely bond one, but in that case, when they collide, they stick together. So to hit and stick, there are a couple of scenarios we have to know. That if two objects approach each other, if they approach each other like this, either from opposite direction or traveling in the same direction, doesn't matter. They collide and they stick together as one object. When they go over there, they stick and they move like this. They move like as a combined, they stick to that. Or the second thing, one object will be in the motion and one is at the rest. If you see that if it is at this one is at rest and this one is moving towards it and they stick over there. So when they stick over there, then they're moving. So this also means they are hit and stick collision. So moving object will collide with the stationary object and they will move together after collision as one object. So in that case, you can see that we have initially both have different things, but after the collision, they both combine. So the final will also be combined, because when they are on this and this, the initial will be different, but when they combine together, one and two, when combined together, they will make a one thing. They will make a one mass, which is the addition of the two masses of one and two, and the velocity is the final velocity is the same for both when they're traveling towards the other direction. So this is formula is like a shortened one, in like a not a bigger one like a hit and rebound. Here we just know that P1I is there. We have P2I also because they have a different initial masses. But after that, they both are combined, so they have a combined momentum 1 and 2. Fine. So we get M1 V1I plus M2 V2I, which is the same as hit and rebound left hand side, is equal to, we get mass of both combined together, and we have a final velocity of both. The both masses are combined and final velocity is 1. So this is the second formula you have to learn for the this one, hit and stick collisions. So let's move on to the example for this. Okay, we have a car example in this. So 1100 kg Nissan car traveling east at 25 km per hour collides head-on with a 300 kg Volkswagen car west at 15 km per hour. Two cars lock together upon impact. They lock means they stick together. Determine the velocity of the combined masses immediately after the collision. We have to find the combined velocity for both. So we have a two things. We have a two masses for both. For first one, we have a 1100 kg mass. For second one, we have about 1300 kg mass. And for velocities, we have separate velocities for both. So V1I is equal to 25 kilometers per hour, and V2I is this 15 kilometers per hour. For this two, like first one is in east, so east we have positive, and for west we get negative. So this 15 should be negative. Then we have to find the combined velocity of both. So we have a formula which is m1 v1I plus m2 v2I is equal to m1 plus m2. So for this question, you move this m1 plus m2 over there, so it divides on this. So we get rid from there. Let's put the thing. So I take velocity in kilometer per hour only because at the end didn't mention that we want this in meter per second or not. This only said we have to find the velocity. So it doesn't matter you calculate in kilometer per hour or the meter per second. So in meter per second this is easy. So they didn't need to convert this into meter per second. So just use kilometer per hour in this. So mass 1 is 1100 kgs. V1I is 25 kilometers per hour plus 1300 kgs M2, and V2I is negative 15 kilometers per hour with 11 kgs plus 13 kg mass addition of both. And we have to find the combined mass. So that combined mass is equal to 8000 kg dot kilometers per hour upon 2400 kg cancel, and we get about combined mass of 3.3 kilometers per hour. This is in positive, so if it's in positive, so this means it's east direction. So this is the combined velocity of immediately after the collision in the east direction. So that's how you have to find the hit and stick with this formula. So let's move on to the last collision. This is not the collision, this is the explosion mode. So which is explosions. So in an explosion, this is a simple thing. When an object fractures into the multiple pieces, they break down to multiple pieces. The object can either be at rest or initial momentum is zero. There are two things. Initially it has rest, or it has momentum of 0. So this means initially we have nothing, we have 0 over there. And it can be in motion, so the initial momentum is not 0. Some cases it can be in motion, some cases it can't be in motion. Pure to the explosion. What type of explosion is this? Is on that. So this means this is at rest. You can see these both objects are at rest. When they explode, they both coming on the different direction. They both moving on the different directions. So this means that explosion happens. So this is number one, this is number two, and when the explosion, so they become one and two. In this, initially we have 0, and now we have the final. So if we have final, so 0 is equal to m1 v1 final plus m2 v2 final. So this is the last one which we have to memorize. This is a small one as compared to the first one. Both are small, the second and two. So that's how it is. Okay. So let's do the example for this. So a cannon initially at rest fires the shell. The recoil velocity of the 3200 kg of cannon is 4.81 meter per second. Determine the final speed of the 70.0 kg shell. So they didn't mention what initially happened. So for this, if they didn't mention what the initial happens, so we just take like initially at rest. So we have the formula which is 0 is equal to m1 v1 f plus m2 v2. We have to find the final speed of 70 kg shell. So if that means we have a mass 1, this is the mass 1, that 70.0 is the mass 2. For mass 1 we have a v1f and we want v2f to find. So the v2f, those isolate, and we get minus m1 v1f upon m2. So for this, mass 1 is 3200 kgs, v1f is 4.81 meter per second upon mass 2 is 70.0 kgs. From here, when you calculate, you get v2f of about 220 meter per second. So this is the easy kind of question of the explosion. But you sometimes get the more complex one like this. So how can we deal with this? Let's figure it out. The same formula will going on, but in some different way now. So 5.2 kg ball is rolling along a level. Low friction surface with a velocity of 2.7 meter per second right when it suddenly explodes into two pieces. So initially we have something that 5.2 kg ball explodes into two pieces. Like this means if you have like 5.2 kg ball, now this ball explodes. When they explode, they come into two pieces, 1 and 2. That 5.2 is the mass of the that two things. But this is the mass of the both the things. And that velocity which is mentioned is of the both. And now they have the separate things. They break down it. So first one is about 3.1 kg piece, 1.2 meter per second they travel left. Determine the velocity of the second piece. So firstly we have the combined mass. Mass 1 and 2 is 5.2 kg, and that combined velocity we have which is the initial, because this they go initially after they collide. So it's a v12i of 2.7 meter per second. So this is right, so we take right as positive and the left as negative. That's okay. That's the first one. that mass 1 only have 3.1 kg. So this is after the explosion occurred. So this one is now V1F. So V1F is a negative, so it's because left, so minus 1.2 meter per second. We have to find the velocity of the second piece. So this of velocity we have to find, which is V2F. And we have a mass of 2. How can we find? This is 3.1 kgs. This is 5.2 kgs. We subtract 5.2 minus 3.1, we get 2.1. So mass 2 is of 2.1 kg. So now we have firstly have a combined momentum. Then we have a final one of both. So that is this. Then V1 final, M1 final, M2, V2 final. You have to find that V2, this one. So I isolate this and you get this minus this upon M2. So put all the things in the bracket and all the things in this. So M112 is 5.2 kgs. Initial one is 2.7 meter per second minus 3.1 kg minus 1.2 meter per second whole to the 2.1 kg. So when you solve that all the things for this one, you get about 7.7 kgs kg dot meter per second upon 2.1 kg. Kg cancel out, and then you get about 8.5 meter per second. This is in positive, so this means this is in the right direction. So that's how, if you get more couplets of explosion, so that type of question you get. Now the previous one which we did. So that's all for this lesson. We left with the one topic of attraction one dimension, but we completed the major part of this topic, which is the collisions and the explosions. This is the most important topic which you most questions about this you get. And when we do two dimensions too, so there's in two-dimensional now. So how can we deal with? We with the later on lessons. But for today, we have to memorize that three formulas to calculate this, and we have to know that question is asking for the what collision or the explosion. So that's all for this. Learning my simple way how to vibe. Learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions related to this topic, let me in the comment section. See you in the next video. Till then, stay connected with EduVibe.